Hello and welcome everyone. I'm Henry, a protocol developer here at Panoptic, and I'm excited to introduce you to the Panoptic Codebase today. In this video, we'll delve into Panoptic and provide you with a comprehensive overview of the general architecture. You'll also learn how to install the Codebase and mint your first PIN option. So whether you're a seasoned developer or just a retail trader, we're certain you'll find something valuable here. Now, let's begin with an overview of what Panoptic is all about. Panoptic is a decentralized and permissionless options trading protocol built on Uniswap v3. We've taken a new and innovative approach that allows us to adapt a novel form of perpetual options into a DeFi protocol with Oracle-free settlement. Instead of relying on thin and centralized order books, Panoptic takes the form of an advanced lending market for Uniswap v3 positions. Uniswap v3 LP positions have payoff curves that are strikingly similar to those of traditional options. Fees collected by positions are essentially a streaming options premium, which we call streamia, that compensate Uniswap LPs for the risks their position carry, which, as we know, are nearly identical to the payoffs of traditional options. The Panoptic protocol leverages this unique property of Uniswap LP positions to offer a full spectrum of options exposure to every Uniswap v3 pool in existence. Because Uniswap LPs have payoffs similar to selling options, we can create a payoff similar to buying an option by removing that liquidity, compensating those LPs with the fees or streamia that would have been collected on their position. Similarly, option sellers can create both calls and puts by borrowing one of the tokens in a Uniswap pool and swapping them into the constituent tokens of their position. These strategies are time-tested and have been employed by savvy retail and professional traders alike. In fact, our CEO and the inventor of the Panoptic protocol, Guillaume Lambert, conceived of Panoptic through executing these very strategies. If you want to learn more about the concepts underlying Panoptic, I would encourage you to read his Panoptic's Genesis blog post series, linked in the description below and in the GitHub README. Panoptic takes these strategies to the next level. We created integrated, under-collateralized, and capital-efficient lending infrastructure for both ordinary tokens and Uniswap v3 LPs that supports management of highly advanced multi-leg positions. This enables several firsts in the DeFi space: leverage on option selling and Uniswap's liquidity provision, leveraged option buying, and a unique commission-based fee structure that options traders will find refreshingly familiar. Before we dive in, please take a moment to follow us on Twitter and join our Discord, linked below. If you've been enjoying this video, I would also suggest you subscribe to our YouTube channel for future videos in this series, where we will dive deep into the inner workings of Panoptic. Now, let's delve into the codebase and explore the architecture that makes Panoptic possible. Panoptic, like Uniswap, runs on Ethereum's EVM and is written in Solidity 0.8. It leverages Foundry as a testing, fuzzing, and deployment framework. A quick note on licensing. Panoptic's proprietary code is licensed under the Business Use Source License, BUSL 1.1, for several years, after which it will convert to a General Public License, GPL. We also have some components that are licensed under GPL right now. You can find more details on this in our license file and README. Now, let's take a closer look at the components that power Panoptic. The Panoptic protocol, as we discussed earlier, is a system of contracts that can be deployed on top of any Uniswap v3 pool. There are three primary pillars that power Panoptic. First off, the Semi-Fungible Position Manager, or SFPM for short. This is a gas-efficient alternative to Uniswap's non-fungible position manager that manages complex multi-leg Uniswap positions encoded in ERC-1155 token IDs. It performs swaps, allowing users to mint positions with only one type of token, and, most crucially, supports the minting of both typical LP positions where liquidity is added to Uniswap and long positions where Uniswap liquidity is burnt. While the SPM is enshrined as a core component of the protocol, and we consider it to be the engine of Panoptic, it is also a public good that we hope savvy Uniswap v3 LPs will grow to find an essential tool and upgrade for managing their liquidity. Next up, we have the collateral tracker. This is an ERC 4626 vault where token liquidity from passive Panoptic liquidity providers, PLPs for short, and collateral for open positions are deposited. Collateral trackers are also responsible for paying out commission fees and options premia, handling payments of intrinsic value for options and distributing P&L, calculating liquidation bonuses, and determining costs for forcefully exercising another user's positions. However, by far the most important functionality of the collateral tracker is to calculate the collateral requirement for every account and position. Each time positions are minted, burnt, or rolled in Panoptic, the collateral tracker updates the collateral balances and provides information on the collateral requirement, ensuring that the protocol remains solvent and we retain the ability to liquidate distressed positions when needed. Finally, we have the Panoptic pool. This contract exposes the core functionality of the Panoptic protocol. If the SPM is the engine of Panoptic, the Panoptic pool is the conductor. All interactions with the protocol, be it minting, burning, or rolling positions, liquidating or force exercising distressed accounts, or just checking position balances and accumulating premiums, originate in this contract. It is responsible for orchestrating the required calls to the SPM to actually create option positions in Uniswap, tracking user balances of and accumulating the premia on those positions, and calling the collateral tracker with the data it needs to settle position changes. Now that we've gone over the core components of the protocol, we can summarize and see how they all fit together. Afterward, we'll do a brief walkthrough through the rest of the codebase and some of the supporting libraries that make Panoptic possible. As we've discussed, Panoptic contains an advanced and capital-efficient lending protocol for both Uniswap v3 positions and their constituent tokens. Each instance of the Panoptic protocol on a Uniswap pool contains one Panoptic pool that orchestrates all interactions in the protocol, 2 collateral trackers for each token in the Uniswap pool, and a canonical SPM that manages liquidity across every Panoptic pool in existence. Within the system, there are 5 primary roles assumed by users. We have Panoptic liquidity providers, or PLPs for short, option sellers, option buyers, liquidators, and force exercisers. Essentially, PLPs deposit tokens into one or both collateral trackers. The liquidity deposited by PLPs is borrowed by sellers to create their positions, and this enables under-collateralized borrowing to create under-collateralized option positions in Uniswap. In return, they receive commission fees on both the notional and intrinsic value of option positions when they are minted. Option sellers and option buyers are PLPs too. They also must deposit collateral to open their positions. We consider users who deposit collateral but do not trade on Panoptic like sellers and buyers do to be passive PLPs. Next, we have option sellers and option buyers. These are the traders of Panoptic. Sellers deposit liquidity into the Uniswap pool through Panoptic, making it available for option buyers to remove or take. This role is similar to providing liquidity directly to Uniswap v3, but offers numerous benefits, including advanced tools to manage risky, complex positions, and a multiplier on the fees or premia generated by their liquidity when it is removed by option buyers. Sold option positions on Panoptic have similar payoffs to traditional options. Option buyers, on the other hand, remove liquidity added by sellers from the Uniswap pool and move the tokens back into Panoptic. The premia they pay to sellers for the privilege is equivalent to the fees that would have been generated by the removed liquidity, i.e. their opportunity cost, plus a spread multiplier based on the portion of available liquidity in their Uniswap liquidity chunk that was removed or utilized. Lastly, we have liquidators and force exercisers. These users forcefully close other users' positions. Liquidators are responsible for distressed accounts that no longer meet the collateral requirements required to maintain their positions. They provide the tokens necessary to close all positions in the distressed account and then they receive a bonus from the remaining collateral for their services. Sometimes they may also need to buy or sell options to allow lower liquidity positions to be exercised. Finally, forced exercisers are usually option sellers. Like liquidators, they provide the required tokens and forcefully exercise long positions from option buyers in out-of-range strikes that are no longer generating premia. The reason for this is so the liquidity from those positions is added back to Uniswap and the sellers can exercise their positions, which involves burning that liquidity. They pay a fee to the exercised user for the inconvenience based on the distance the current tick is from the strike of that user's position. Every Panoptic user gets started by depositing tokens into one of the collateral tracker vaults for one of the tokens in the Uniswap pool, and they're issued shares, becoming PLPs in the process. The collateral tracker supports the full ERC4626 vault interface, making deposits and withdrawals a simple and standardized process. Passive PLPs stop here and don't interact with the protocol in any other way. Once they've deposited, there are many options for other actors in the protocols. Traders, buyers, and sellers can call mint options to create an option position, which with up to 4 distinct legs with a specially encoded position ID or token ID, each of which is its own short, sold added, or long, bought removed liquidity chunk. Then they can burn options, which allows them to burn or exercise a position they created through mint options, closing it. Finally, they can roll options, modifying the liquidity chunk of one or more legs in the position they created through mint options, transitioning it to a new position ID, but retaining the same size, only paying commission on any changes in the intrinsic value of the option. This only modifies the required legs in the position and is a far cheaper and more gas-efficient alternative than entirely burning and minting a position through mint options and burn options, enabling frequent rebalancing, which is often required to be an effective Uniswap LP or option seller. Forced exercisers and liquidators can perform their respective roles with the specialized forced exercise and liquidate account functions, allowing them to close accounts positions when it is appropriate. That was an overview of Panoptic's architecture. In future videos and blog posts, we'll dive deeper into the technical details of how the protocol works. For more information, I would recommend checking out our light paper, white paper, and documentation, all linked below and in our Codebase README. We're also active on Discord and happy to answer any and all questions you may have about Panoptic. Now, let's briefly explore the rest of the Codebase and learn how to mint our first Panoption. Because Panoptic is built on top of Uniswap v3, we use interfaces and libraries from their Codebase to perform related calculations and interactions. All the libraries we use from Uniswap can be found in this contracts/external folder. The versions of these libraries are the same time-tested ones used in their protocols, but have been slightly modified to improve gas efficiency and compatibility with Solidity version 0.8. Panoptic leverages several custom types to make code more efficient and concise. Generally, they pack multiple pieces of smaller data into 256-bit signed or unsigned integers. The tick-state call context type contains a current tick, a median tick, and a caller address. It is frequently passed to the collateral tracker from the Panoptic pool, providing it with contextual information it needs to check and update the collateral for a given user. The left-right type stores two 128-bit signed or unsigned integers in a single 256-bit type. This is often useful in storing data about the tokens in the Uniswap v3 pool, such as a balance. Since there are 2 tokens in every Uniswap v3 pool, balances and other data for both of these tokens can naturally be stored in one of these containers. The liquidity chunk type is how we represent a single Uniswap v3 liquidity chunk in Panoptic. It contains a lower tick lower, an upper tick upper, and a size or amount of liquidity. Each leg in a Panoptic position codes for 1 liquidity chunk. Finally, the token ID type defines the encoding of a position in Panoptic and the SFPM. Each time a position is minted, an ERC1155 token ID with this type encoding is minted by the SFPM and stored by the Panoptic pool. It contains a unique 64-bit identifier that specifies what pool the position is to be minted on, as well as up to 4 legs, each with the ability to specify a unique liquidity chunk, whether the leg is long or short, what token should be used to mint the position, its relative size compared to other legs, and more. Panoptic's contracts also make use of several libraries to help perform calculations and more. The errors library contains all custom errors used in Panoptic's core contracts. FeesCalc is a utility to calculate up-to-date swap fees for a given liquidity chunk. Interaction Helper contains helpers to perform bytecode-sized heavy interactions with external contracts, such as batch approvals and metadata queries. Math is a library of generic math functions, including the absolute value function and several optimized 512-bit MOLDIV functions. Panoptic Math is a library containing advanced Panoptic or Uniswap-specific functionality, such as our TWAP, price conversions, and position sizing math. Several of Panoptic's contracts are also tokens. The SFPM issues ERC 1155 tokens to represent Uniswap positions, while the collateral tracker, being an ERC 4626 vault, issues ERC 20 tokens to represent shares of collateral. They inherit from the contracts in this folder, ERC 1155 minimal and ERC 20 minimal, respectively. And these are minimal implementations of the relevant token standards without metadata, which is specified in the inheriting contracts. The ERC20 partial interface in this folder contains several functions in the ERC20 interface that we call on tokens. The success return value from some of the functions, such as approve or transfer, has been omitted in order to ensure support for certain non-compliant tokens, like USDT, that do not return anything on success. Finally, this multi-call contract is inherited by all of our core contracts and allows users to batch multiple calls to a contract in a single transaction by passing the call data as an array. For example, you could use the multi-call feature on Panoptic Pool to mint 5 different positions at the same time, saving gas and improving your experience. We hope you enjoyed that overview of the Panoptic codebase. Now, let's wrap things up by learning how to install the codebase and mint your first pen option. Let's install the codebase by following the instructions in the README. First, clone the Git repo. Make sure you remember to pass the recurse submodules flag, since some of our dependencies are in submodules. Then, cd into the directory and install prettier and our pre-commit hooks by running npm install. Every time you commit, your code will be automatically linted. To compile and run our code, you will need to make sure you have Foundry installed. If it's not installed, go to getfoundry.sh, link below, and follow the instructions to install the latest version of Foundry. Now that everything has been installed correctly, we can finally mint our first pen option. Let's get started by deploying a new instance of Panoptic on Sepolia. You'll need some Sepolia ETH from the Alchemy faucet, link below, for gas. The deploy script for Panoptic needs to know the private key for your account, the address of the Uniswap v3 factory, as well as the address for wrapped Ether on whatever chain you're deploying it on. We need to export these as environment variables as specified in the README. So let's go ahead and do that. Now, let's run the deploy script and deploy a new Panoptic factory. Alright, now let's fill in the new SFPM and Panoptic factory addresses in our script. We're going to deploy a Panoptic pool on the wrapped Bitcoin DAI 5 basis points pair. To do this, we're going to approve the Panoptic factory we deployed earlier to spend our wrapped Bitcoin and DAI so it can perform an initial full-range liquidity deployment. Now, we're going to call deploy new pool on the factory. To do this, we pass in the addresses of the tokens constituting the pool that we're going to deploy the new Panoptic pool on, the fee in hundredths of basis points of the pool. So this is 500 hundredths of a basis point, or 5 basis points, and a salt, which is completely random that we've chosen here, used while creating the Panoptic pool. If we wanted, the salt could be used to mine a vanity Panoptic pool address. For example, if we wanted to prefix it with several zeros. Before we deposit collateral, we'll need some test wrapped Bitcoin and DAI. We can grab these from the Aave faucet, link below. Now, we'll need to approve the respective collateral trackers on the new Panoptic pool we deployed for the tokens we're going to deposit. The Panoptic pool exposes the addresses of these collateral tokens. Let's deposit some wrapped Bitcoin and DAI as collateral now. Finally, we can get started minting our PAN option. Let's dissect the parameters we're using here to mint our options. First, of course, we need to add the pool ID to our token ID, so the SFPM knows which pool we want to mint our option on. The pool ID is exposed on the SFPM, since it is not always completely derivable from the pool address. Then we can use a handy function in the token ID library called addLeg that takes all parameters from one leg of the option and adds it to our token ID. Let's dissect the parameters that we're using here. The leg index is the position of the leg in the token ID from 0 to 3. Since this is our first leg, we just set it to 0. The option ratio is the relative size of the leg compared to other legs. The position size is multiplied by this amount when creating the leg. It allows you to create legs of different relative sizes. The asset is the token we're using to size the leg. We pick token 0 since we want to size in terms of DAI. We're minting a short option, adding liquidity to Uniswap, so we set isLong to 0. Since we're minting a put, we set token type to 0. This means that we pay for the option and borrow from PLPs in terms of DAI. If the price of wrapped Bitcoin falls below our strike, our position will begin to decrease in value, since we owe DAI to PLPs, but our Uniswap LP is composed of wrapped Bitcoin at that point, which is depreciating in terms of DAI. This is what makes the payoff similar to a traditional short put. The risk partner we set to index 0, or in other words, this leg. The risk partner is used to specify defined risk positions, such as strangles, in order to calculate collateral requirements. Some combinations of options have a lower risk when combined, so the collateral requirements can be lowered in certain cases. It is set to the index of the other leg in the defined risk position, and set to the index of its own leg if we are not taking advantage of this feature, which is what is happening here. Next, we set the strike to tick 5,000. Currently, the price in the wrapped Bitcoin DAI pool is at tick negative 1,700. Since price in Uniswap is represented as token 1 over token 0, this means that the higher the tick is, the lower price in DAI token 0 of wrapped Bitcoin token 1 is. We're minting an out-of-the-money option, so we want the wrapped Bitcoin price to be above our position when we mint it. As we discussed, it becomes in the money when the price of wrapped Bitcoin falls below our position. This means that we should pick a higher tick than negative 1,700. One example, like we're doing here, is 5,000. Finally, we set the width to 2. While Uniswap pool prices can be at any tick between the maximum and minimum ticks, most pools, save for 1 basis point stable pools, have a tick spacing. meaning the upper and lower ticks of LP positions can only be specified in increments of tick spacing. For 5 bips pools like this one, the standard tick spacing is 10. We take this into account in our sizing system. The position width specified in the token ID is multiplied by the tick spacing of whatever the position is being minted on. This means that the tick spacing of 2, as we have specified here, corresponds to a tick lower and tick upper 20 ticks apart. In this case, 4990 and 5010, 10 ticks above and below the strike. Finally, let's mint our pin option. First, we need to pass in a list of positions, which we have constructed here. The position ID list contains a list of current open positions that is checked against a stored hash and used to determine account solvency. When minting options, the position being minted is placed at the end of the list. In this case, since we do not have any open positions, the entire list is just this position. Then we need to specify a position size. Since our position is OTM, our token type is 0, DAI, and we're specifying the asset or value in terms of DAI. Putting this amount 10 times 10 to the 18 here means that our position will be worth 10 DAI, since DAI has 18 decimals. The effective liquidity limit is an optional parameter that allows us to specify an upper bound on liquidity utilization for a certain liquidity chunk. Option buyers will use it to ensure that the portion of liquidity they remove by buying options, and therefore their premium multiplier, stays below a certain threshold. Since we are selling options, we don't need to worry about this and can leave it off. The tick limits allow us to specify a maximum slippage value, similarly to Uniswap. The tick at the end of the option mint is verified to be between these limits before the transaction ends. We're going to leave these off too, since we're not too worried about slippage here. Now, let's run the code and mint our first pin option. All right, let's take a look at our transaction in the Sepolia Scan Block Explorer. Make sure it succeeded. As you can see, we've minted an option worth 10 DAI successfully. If you've gotten to this point, congratulations. You've taken your first step in using Panoptic and learning about the intricacies of how it works. Thank you for joining me today in this introductory exploration of Panoptic. I hope you found it interesting and informative. If you want to, we encourage you to check out our website and documentation to learn more. And feel free to reach out to us on Twitter or Discord if you have any questions or feedback. Stay tuned for our next video, where we'll delve deeper into Panoptic's technology. Until then, happy trading and see you next time.